video on scientific notation. By the end of this video, you should be able to represent very large or very small numbers using scientific notation, as well as use operations such as addition, subtraction, multiplication, and division with numbers that are in scientific notation. So scientific notation was developed to help represent numbers that were very, very large or very small, and it kind of put everything on the same kind of scale so you could understand. It was easier to look at and made it a little bit easier to work with the numbers. And it's times 10, using the power of 10, because our number is a base 10 system. All right, in a scientific notation, all the problems are set up in the same format. You have a part 1. Part 1 is a number between 1 and 10. Not less than 1 and not more than 10. Okay, and in part 2, you will always have times 10. Okay, so that's your part 2. Part 1, remember, is a number between 1 and 10. And the final piece that you're going to have is in part 3, you're going to have an exponent. And your exponent can be positive or it can be negative. And it's telling you how many times the decimal was moved from the original number. And the positive and negative helps you understand the direction of the movement. So let's do a little bit with this to help you see what's going on. All right, numbers that are large will be expressed using positive exponents. So here we have our number 65 million. So we want to move the decimal to create a number that's between 1 and 10, and then we're going to count how many times we move the decimal. So the decimal is currently located right there at the end of the number, and I need to move it all the way over until I make a number between 1 and 10, which would be all the way between the 6 and the 5. So we're going to have 6.5, that's our first part, it's between 1 and 10, times 10 is always the second part. Now, how many times did the decimal have to move? It moved 1, 2, 3, 4, 5, 6, 7 times. So your decimal will be 7. So somebody looking at this go, oh, that's a positive number. So this decimal will move 7 times to the right. So let's try it again. We have 548. The decimal is right there at the end of the 548. If I move it 2 times to the left, I'll have a number that's 5.48, which is between 1 and 10, times 10, and I moved it 2 times. Okay. And for our final example, 943,000, our decimal is located right there at the end. I need to move it so I make a number between 1 and 10, which would be 9.43. So if I can get the decimal to right there, 9.43 is between 1 and 10. And how many times does that decimal have to move? We have 1, 2, 3, 4, 5 times. So its exponent is 5. So when I moved my decimal to the left, I added exponents. Okay, moving the decimal to the left, added the exponents. All right, let's look at what happens with small numbers. So in the big numbers, I was always moving my decimal to the left. Well, with the small numbers, I need to move my decimal to the right to make them bigger. So if I want a number between 1 and 10, 6.52 would be between 1 and 10. So I have 6.52 times 10, and we got to see how many times does that decimal move. It moves 1, 2, 3, 4, 5 times, but small numbers will be expressed with a negative exponent. So we'll write -5 there. Let's try it again. I need a number between 1 and 10. So if I move the decimal to right there, my number will be 7 times 10. And it only had to move 2 times to the right. So I made a smaller number bigger, so it gets a negative exponent. One last time, that is a lot of zeros. Hopefully you can see the decimal is going to have to go here between 7 and 5. So I'll get 7.5 times 10. Now, how many times did that decimal have to move? So it moved 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times. So we made a smaller number bigger because 7.5 is a bigger number than that point blah 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 is 7.5, right? So it has a negative exponent. So when I moved my exponents to the right, I was actually subtracting exponents. Okay, that's going to become important soon. So let's take a look. What if I gave it to you a number in scientific notation form and I wanted you to write it back into standard form? Okay, so 4.75 times 10 to the 7th. That's a positive exponent. Remember, big numbers have positive exponents. So that actually means I'm going to go 7 places to the right. So we already have 2 places there. So 475. The decimal started right here. So there's 1, there's 2. I need to move 5 more. 3, 4, 5, 6, 7. There's where my decimal is going to be. So what I'll need to do is fill in all those extra jumps with a 0. And when I look at it with commas in it, that number is 47,500,000. So it's a very big number. It's just a little easier to deal with in scientific notation. So let's try it again. So I have 7.65 times 10 to the negative 6. Very small numbers have negative exponents. So to have been put in that exponent, the decimal was moved to the left. That means you got to move to the right. That means you got to move it to the left to put it back. So we have, there's the basic number. The decimal was here. And I need to move it 6. So I got 1, 2, 3, 4, 5, 6. That's where the new decimal is. So we got to fill all of that extra spots in with 0. So we have 0.0000765. All right. Take a look at number 9. 9 has a negative exponent, so that means you're making a smaller number. This one is only going 1, so it's going to move 1 to the left, so that will be 0.49. And then number 10, we have 10 to the 4th. The 4 is a positive number. We're making a bigger number, so we're going to move to the right. 1, 2, 3, 4. So I have 2 places that have nothing in it, so I'm going to fill those in with zeros, 314, and then I had 2 zeros for 31,400. All right, so that's kind of a review of what you've done with scientific notation. Now, we're going to do some operations with scientific notation. First, we're going to begin with adding and subtracting. So when you add and subtract, your exponents must be the same, just like when we work with exponents any other time. The exponents must be the same to add and subtract. You may need to move a decimal to make the exponents match before you can add or subtract. So we're going to use the same rules up here when we're in scientific notation moving decimals. And if we're going to move to the left, that means we're adding exponents. If you have to move your decimal to the left, you're adding to your exponents. If you move your decimal to the right, that means you're going to be subtracting to your exponents. That's going to help you figure out what you've got to do to match. So in our first example, we have 2.3 times 10 to the second plus 5.3 times 10 to the second. Their exponents match. That means we can jump straight into this. And if we take 2.3 plus 5.7, we get 8. Then the second part is times 10. And remember, when you're adding or subtracting, you don't change your exponents. They stay exactly the same. So that will be 10 squared. Okay, let's take a look at number 12. 12, it gets a little more complicated. I have 2 different exponents. I have an exponent of 6 and I have an exponent of 7. I need them to match. So I'm going to recommend you always make it to the bigger exponent. It's just an easier way in the end for us. So if I want to make the 6 look like a 7, that means I need to add 1. So if I need to add an exponent, that means I need to move my decimal left however many I need. So if I need to add 1 to that, I need to move the decimal left 1 to make that happen. So this really is now 0.12 times 10 to the 7. And then we have plus 5.9 times 10 to the 7. Now their exponents are the same, so I can just add them together. 0.12 plus 5.9 is 6.02 times 10 to the 7th. Okay? So I know these make you think. So and it really doesn't matter which one you change, but sometimes you might have to move exponents at the end. So let's take a look. If I wanted to make this -4 look like a -6, that means I'd have to subtract 2, because -4 minus 2 is -6. So if I need to subtract exponents, that means I need to move my decimals right, and I said I needed to do 2, so I'm going to move it over 1, 2. So that gives me 734 times 10 to the -6 minus, we don't have to change anything here, we only had to change 1 to make a match. Now their exponents match, so we're going to take 734 minus 2.74, and I got 731.26. So 731.26 times 10 to the -6. So this is why I was suggesting you actually change your exponents to the bigger number. We changed it to the smaller number. And if you notice this part 1 here, that is more than 10. So this decimal actually needs to move 2 to the left in order to be a number between 1 and 10. So I would get 7.3126 times 10, and I moved left 2. So if I move left 2, I have to add my exponents. So -6 plus 2 would be -4. Okay, and so that's what I was saying. -4 is the bigger exponent. That's usually the easier one to move to. So let's take a look at number 14 using that thought in mind. We have an exponent to the first and an exponent to the -1. The 1 is the bigger one. So we're going to leave that one and make the other one match it. So 3.5 times 10 to the 1 minus, I need to add 2 because -1 plus 2 equals 1. So I need to add 2. If I need to add exponents, that means move my decimal left 2, which would give me 0.074. That's moving this decimal twice, times 10 to the first. Now that they're the same, I can take 3.5 minus 0.074, and I got 3.426 times 10 to the 1. All right, so hopefully you're kind of getting the feel for that. I would take this information, we're going to flip this over, go ahead and write it at the top of the back of page. That might be helpful too. Let's flip it over. All right, on the back here, we're going to multiply and divide exponent with our scientific notation. It's actually a little bit easier. We're going to just follow our product rule and our quotient rule for changing our exponents, just like we've done in the past. The only thing we have to be sure is, like we did on the front, if our final part 1 is not less between 1 and 10, we have to move an exponent to make it work. So let's try. So it doesn't matter if the exponents match or not. We're just going to take 2.7 times 1.8. Okay, so you're going to multiply them using your calculator. 2.7 times 1.8, and I got 4.932. Part 2 is just times 10. All right, and then If you're multiplying like bases, these are both tens, you're going to add their exponents. So that gives us 8 tens. So 4.932 times 10 to the 8, that is a very large number that we were able to write in a more manageable way. So we used our product rule when we multiplied our like bases. Product rule says the base stays the same, add the exponents. Now we're going to divide. Dividing works the same way as we divided before. You're going to divide the numbers, and when you come to the like bases, our rule was we subtracted our exponents. Okay, so in previous, we did not keep a negative exponent, but in scientific notation, it's perfectly allowable because it's letting you know the size of the number. So we're going to take 1.4 divided by 8, and I got 0.175. There's my part 1 times 10. Now let's look at the exponents. We have negative 5 minus negative 4. So negative 5 minus negative 4 is negative 5 plus 4, which is negative 1. Okay, but we're not finished because our part 1 section is not between 1 and 10. We actually need to take this decimal and move it 1 to the right. So I have a number between 1 and 10, so 1.75 times 10, and I moved it to the right. So that means I need to subtract an exponent, so negative 1 minus 1 more is negative 2. Okay, let's try it again. We're multiplying this time. So we're going to multiply 4.3 times 5.8, and I got 24.94 times 10, and we have negative 3 plus 6 is 3. But we are not finished because our part 1 number is not between 1 and 10, so we got to take it and we got to move the decimal 1 to the left. So we have 2.494 times 10, and we moved 1 to the left. So when we look back up here, we add an exponent. So we moved it only one time, so 3 plus 1 is 4. All right, now let's take a look. We got division again. We're going to divide the first two numbers. 5.4 divided by 5.9 is a really long decimal, but I'm going to put 0.9153 times 10, and then let's look at our exponents. We have negative 3 minus 6 more gives us negative 9. But our first number is not between 1 and 10, so we're going to move the decimal 1 to the right. So we get 9.153 times 10, and if you move your exponent to the right, you have to subtract 1. So that gives us to the negative 10. All right, two last ones. Go ahead and pause the video and come back and see how you did. All right, on your last two, both times you ended up with numbers not between 1 and 10, so you had to move the decimal. We moved the decimal 1 place to the left each time, so if you move left, you add your exponents. So I got for my final answers 6.351 times 10 to the third and 2.814 times 10 to the third. Hopefully that was helpful. Let me know if you have any questions. See you in class.
Yeah.